This is Math 2, is where you learn quadratic equation. You might have learned a song. There's many, many songs out there. I don't know who taught it to you or what you may have learned there. But I would put quadratic equation on my note card because, on the actual exam, of course, you would have to have it memorized. But well, I'm not going to say for sure. Definitely, though, for this next test, you may use your Unit 3 note card and the one that you have for Unit 2 as well. So, and I feel like I will probably let you guys use note cards on my classroom test for this class. And then when we do our exam review, we'll try to really cram and memorize all those formulas. So quadratic equation. Whenever you're doing the quadratic equation, you need the x squared to be first, the x to be in the middle, and the number that is a constant by itself at the end. There is a 1 in front of here, even though we cannot see it. So for this, our a value would be 1, our b value would be -5, and our c value would be -8. This is useful. It will work for any equation, not just ones that will not factor. So like if you forget how to factor, you could use this instead. But this particular problem won't factor. Because if I'm trying to factor this like into my parentheses here, I've got an x here and an x here. I got to get -8. The only things I can multiply to get -8 are -2 times 4 and +2 times 4, -1 times 8, and +1 times 8. And do any of those give us -5? They do not, right? So this one will not factor. You cannot use that to solve this. So instead, you would need to use quadratic formula or completing the square. But we are not going to really worry about completing the square until we have to. So quadratic formula is what we're going to use. So -b, so I end up with a -5. What is -5? +5, right? So plus or minus square root -5 squared minus 4 times 1 times -8 all over 2 times a, which is 1. So this is going to be 5 plus or minus. You can do that part in your calculator. If you do -5 squared is 25. 25 plus 32 is what you're going to get. Oh, wait. We're going to get 57 underneath that square root. All over 2. Right there. So our solutions are 5 plus square root of 57 over 2 and 5 minus square root of 57 plus 2. It's actually two different solutions. One of them with the positive, one of them with the negative. Uh-huh. Yes. Yeah, so right here, that'll be a plus or minus both times. So what that means is you've got, really it's two answers. So it's 5 plus the square root of 57 divided by 2, which if you want, you can use your calculator and figure out what that is. You can get a decimal for it. So if you do 5 plus square root of 57 and divide that by 2, you'll get 6.275, so about 6.275. And then the other answer is 5 minus the square root of 57 divided by 2. So if you wanted a decimal for it, you don't necessarily have to get the decimal, but 5 minus square root of 57 divided by 2, that's going to give you -1.275. So we can leave our answer just like this with the plus or minus, but just know that really is two answers there. And sometimes it might be fine to use the decimal, in which case we are going to learn a different way. We could just graph it. But sometimes, excuse me, they want us to have this, what they call the exact answer, one that hasn't been rounded for a decimal. All right, we okay there? All right, so here is an example of when we would need to use this. So I have got to find all of the x-intercepts of the function below. And one way we can find the x-intercepts, right, is just to graph it on Desmos. So if I graph this on Desmos, here, if I graph this on Desmos, I will get 0 at negative 1.742, at 1.5, which is actually a decent number to deal with, and 5.7 something that I can't see because this is in my way, 5.742. So as long as your problem will let you put in decimals, you could just graph it and find the zeros. That would be fine. But sometimes it may ask for the exact answers. And when it says exact, it means it does not want the decimal approximation. It wants it with all that square root stuff still in it. I know it is kind of an annoying answer to have all of those square roots still in it, but it's considered the exact. So whenever we're looking for x-intercepts, the way that we were finding x-intercepts when we began these notes, it was we were trying to find something that would give us 0 when we plugged it in, right? So on that first part, we can do it no problem. We got 2x minus 3. We want to know what will make that equal 0. This is a very straightforward one. We just need to add 3. So we get 2x equals 3. And then we need to divide by 2. So x is going to equal 3/2, which was that 1.5 we saw on the graph, right? 3 divided by 2 will give us 1.5. So that one is just like the other problems that we were doing. Over here, if I want to do that, then I would need to factor further. But if I got negative 10, if I want to multiply, it'd be negative 2 and 5. It'd be negative 1 and 10. I could switch the signs. Am I going to be able to factor that and get a negative 4 in the middle? I'm not. So this one will not factor. So I've got to think about x squared minus 4x minus 10. What would make that equal 0? And since it will not factor, I've got to use quadratic formula for this. So I would do x equals, well, first let's do our a for this would be 1. Our b would be negative 4. Our c would be negative 10. So to plug that in, we would have negative b, which would be negative negative 4, which is really just a positive 4, plus or minus square root b squared minus 4ac all over 2a. When you type this part right here into the calculator, do please be careful, because many of you are going to do this, negative 4 squared minus 4 times 1 times negative 10. And you shall get 24. And you shall be wrong. What is wrong about that? What did I do wrong when I typed that in? There's one little thing. I don't want the square root right now because if I do, it'll give me a decimal. I just want to know like what number is under that square root. So I am on purpose leaving out the square root. So if I'm trying to type in this stuff underneath that square root, what did I do wrong? I missed the parentheses on that -4. It makes a difference in your answer. You will get 56 if you do it this way. Okay, so I will get, let's go back. So I've got 4 plus or minus the square root of 56 all over 2. Now, there is a way I could break down that 56, but we're going to talk about that in a minute, so I'm going to just leave it like it is right now. Okay, so that's my other 2 zeros, right? I've got the 3 halves, and then I've got 4 plus square root of 65 over 2, and 4 minus square root of 65 over 2. Okay? Now, it's important that you understand these are still real zeros. The answer does not include an I. We don't have a negative under a square root that would give us an I. So these are still real. You still see them on the graph. If I graph this, there's going to be 3 zeros that I can see. It's just we're going to have crazy decimals for some of them. Those are still real. Imaginary imaginary zeros cannot be seen from the graph. You won't see them at all. Okay, questions here? All right, so let's continue on. All right, let's do a little bit of review here. And maybe something new depending on whether or not you've seen 6 or 7 before. So, 4 should be definitely a review. What is the square root of 25? It's 5. 5 times 5 gives us 25, so the square root of 25 is 5. We got that. All right, what about square root of 32? That's going to give us a decimal, right, if we type it in. So, it didn't ask us to give the decimal. It said simplify each expression. So, something that you do, I believe, in Math 2, I know Miss Martin said that she did this last year. I don't know how much time you spent on it, but she did do it. If I've got square root of 32, I can break it down. And so what I want to do is I want to think of the numbers I do know how to take the square root of, right? I can take the square root of 1, but it is just 1, so that's not very helpful. The next number, 2 times 2 is 4, so I can take the square root of 4. And what's the next one? Not 6, because it's not 3 plus 3. It would be 3 times 3, which is 9. What's the next one? What's the next perfect square? Here's what we call them. There's one before 5 times 5. 16. Then we'll do 5 times 5, which will give us 25. Then 36, 49, 64. We could keep on going forever, right? But these numbers are called perfect squares because we can take the square root of them and get a whole number. So 32, what I want to try to do is break it down into 2 numbers that are multiplied to give me 32. And one of those numbers, I want it to be one of these perfect squares. So what could I use here? What? 25 times what? You got to be multiplying. 25 times anything will not give me 32. So it's only 25. 16 times what? Times 2. Now, 8 and 4 will also work, but you want to use the biggest perfect square you can use. So 16 is better than 4. If you do 8 and 4, you got to break it down again. So when I do this, it really means square root of 16 times square root of 2. What is the square root of 16? It's 4. I'm taking the square root of it. It's no longer underneath the square root. But the 2, I cannot take the square root of. So it has to stay on the inside. No number times itself will give you 2. So it stays on the inside. Do you guys remember doing that? Like seeing it before? All right, now what I'm not sure if you've seen, you may or may not have seen, is what we do when we have negatives. Because 16, I know the square root of 16, right? Did I tell you guys, maybe it was your class I was telling my joke back there too. My square root of 16 joke. Right, so this is square root of 16. You know, back there, remember, I got this guy, and this guy, and this guy has glasses right here, and this guy over here is saying square root of negative 16 to him, right? So I know the square root of 16, but there's no number times itself that will give me negative 16. Like if I use negative 4 times negative 4 is positive 16. Doesn't work, right? So I can't take this square root the same as I would if it was just positive 16. So I can break this up into 16 times negative 1. All right. What is the square root of 16? Okay. What is the square root of negative 1? It is I. Right? Remember back there on my banner? That square root of negative 1 right there means I, so I love math. So what is this guy calling this guy? He's calling him 4 eyes with his glasses over there. Second period asked me if they were allowed to call me a square root of negative 16. And I told them they can, because I will be impressed that they know square root of negative 16 is 4 eyes, or 4i. So I don't mind. I don't give you permission to make fun of anybody else with square root of negative 16. But you can call me that. I'll be impressed if you do. Yeah. Okay. So. All right, so let's look at 17. 17 is a little more complicated than 6, or not 17, 7. Let's look at 7, which is a little more complicated than 6, because do we know the square root of 150? No, it is not a perfect square, but we can break it down. So if we break it down, which one of these numbers would go into 150? 25. We could do 25 times 6, and then I'm going to put times negative 1 over here. What is the square root of 25? It is 5. What about square root of 6? It is not 3. 3 times 3 is 9. It doesn't have one. So if it does not have one, we leave it underneath the square root over here. What about the square root of negative 1? I. So the I goes out here. We usually write it like this with the 5i in the root right there. So this would be our answer. Basically, the difference between number 5 and number 7 is if you have that negative under there, you're still going to just break it down the same, but that negative is going to become an I. So if you have that negative, you should have an I somewhere in your answer. Okay, so let's look at why we need this. They possibly might ask us for the roots of this function right here. And I could graph it. In fact, let's graph it. Let's graph it here. We got 2x minus 1. X minus, what was that, a 5? And then x squared plus 25. Alright. Let's see. Y equals, why is it not graphing that? Oh, I didn't write my 5. There we go. Okay, so if I graph this, I have a 0 here at 0.5 and a 0 here at 5. I don't see any other zeros. I could zoom out. There are no other zeros. What does that tell me about the other two zeros? They're imaginary. I can't see them on the graph, so they are imaginary. So you are not going to be able to do those problems solely by the graph because you can't find the imaginary roots. But it's not too terrible to find these. So if we wanted to find the zeros, we just needed to find what would make each one of these 0, correct? So if I do 2x minus 1 equals 0, could add 1 to both sides. I got 2x equals 1, divided by 2. There's my x equals 1/2. I saw that one on the graph. It was 0.5, right? Over here, this one's a really simple one. X minus 5 equals 0, so I just add that 5. You could probably do that without writing anything down. X equals 5 would also make this 0. So those are the two real zeros. They're the ones that showed up on the graph. This is where I'm going to get my imaginary 0. If I take x squared plus 25 and set it equal to 0. So, Laura, what would I do to solve that? Good. So I will get x squared equals negative 25. Then, Miles, what do I have to do to get that x by itself? Not log, and second period said the exact same thing. Log would be if we had like 2 to the x power. We would need to log that. What would I do, Paloma? Square root. We would square root right here. Do you guys see the difference between those? Because they're really similar. Here, the x is in the exponent. That's when we need logs. That's where we got a log base 2. That. Here, my x is not the exponent. It's the square I'm trying to get rid of. So to get rid of that, I square root. You should not see anywhere in like Unit 3 stuff where you got to use a log for these. So that's going to give me x equals, when I square root both sides, I'm going to put a plus or a minus with it. What is the square root of 25? 5. But I got a negative, so what do I need with it? I got to put the I there. So this is 4 zeros here, because this right here is really 2. It's a positive 5i and a negative 5i. And it should be 4 zeros because I got 1x here, 1x here, and then 2x's here, so it's a 4th degree polynomial. Okay. Now, 9 is more difficult than 8. Because for 8, it was already factored for us. We just had to set those equal. 9, there's a chance maybe that it is, there's a chance that 9 has real zeros. If it has real zeros, I should be able to graph it. So let's see what it looks like whenever I graph this one. I got y equals x to the 3rd minus 4x to the 2nd plus 16x minus 32. Alright. Ooh, this is not looking good for me. I got it. I do have a 0. I think I typed something in wrong. Was there a number in front of that? Oh, yeah, let's put that 2 right there. Okay, so I do have a 0. It is at 2. That's good. But do you see any more? Does it look like this graph like takes a turn back down anywhere? No. So what I'm probably seeing here is that I got one real 0 at 2 and the others are imaginary. So I can't find those from the graph. So I know based on what I'm seeing here, well, come on. All right, I know based on what I'm seeing here that x equals 2 is a 0. That should be one of them. But it says find all zeros, and that is not all of the zeros because how many zeros does this have? It's got 3 because it's third power, so I should have 3 answers for this. So here is what we're going to have to do for this problem. What I really want is I want to have this factored, and if x equals 2 is an answer, what was the factor that went with that? It won't have just it's got to have an x with it. Like, let's go back up here. x minus 5, what's the 0 that goes with that? X equals positive 5, right? So if my 0 is x equals 2, what's the factor that goes with it? X minus 2. Okay, so opposite sign there. So what I need is I need to factor this where I've got like, I got this x minus 2 times something here. But this is not like one where we can guess and check, really, right? Well, maybe you could. It wouldn't be easy if you did. It would not be easy if you did. So, but if these two things are multiplied together and it gives me this, the way I can find what needs to go here is I can divide. So I can do x minus 2, and I can divide that into 2x to the third minus 4x squared plus 16x minus 32. So this is one of the few types of problems where you're going to have to pull that division back out. Okay, so to divide, I've got to ask myself, what number times x would give me 2x to the third? Almost. If I put a 2x times x would give me 2x squared. I want 2x to the third, so I need to use 2x squared, right? 2x squared times x gives me 2x to the third. And then I also have to multiply 2x squared by the negative 2, which gives me negative 4x squared. Okay. So I divided, I multiplied, now I've got to subtract. So I'm going to subtract this, which actually really becomes like I'm adding, right? Oh, everything just cancels out, right? Got positive and negative, everything cancels out. So when I bring down for this, I'm going to have to skip a spot, and I'm just going to bring down my 16x minus 32. Okay, then I've got to ask myself, what times x would give me 16x? 16, a positive 16, all right? So I'm going to put plus 16. 16 times x is 16x. 16 times negative 2 is negative 32. If I subtract that, I'm just going to get 0 because they're exactly the same. So I have divided this, and I got 2x squared plus 16. Okay, now finding zeros from this, getting here is the hard part. Finding zeros is not too awful bad. I've already found this one really. X minus 2 gives me x equals 2, right? Just set that, what we're doing was say x minus 2 equals 0, so x equals positive 2, right? Just adding that 2 over. So I got to do the same thing over here. I'm going to have 2x squared plus 16 equals 0. Peyton, what do I have to do to solve that for my x? What would you divide by?
Subtract.
Let's subtract that 16 first. It's a possibility, but subtracting first will make it easier. And then divide. So I've got x squared equals negative 8. How do I get rid of a square? Not a log. It's a square root, right? So logs are for whenever we have like 2 to the x. Square roots is whenever we've got x squared. So we square root right here. So I've got x equals plus or minus square root of negative 8. They're probably not going to write it like that. They're probably going to... There's going to be an I. So we're going to break this down. Will 8 break down? Is there a perfect square that will go into 8? 4. So I could do 4 times 2 and then times that negative 1, right? So for this one, what is the square root of 4? 2. The square root of 2? I cannot do, right? So I'm going to leave that over here underneath the square root. And the square root of negative 1 is my I. That's where the I comes from. So you got x equals 2, and you got x equals plus or minus 2I squared of 2. That is 2 zeros, because one of them with a positive, one of them with a negative. So there's your 3 zeros you're supposed to have. Okay, questions? Okay, that's as difficult as it's going to get for you guys. Those would be like your most difficult types of problems. And you would have to be able to find imaginary zeros. You have to be able to divide for that. A lot of other things you can get by using Desmos or something, or even like right here, you don't have to know how to divide because it's already factored for you. Okay? All right, here's our next one. Now, it is perfectly fine on this one to graph it. You could graph this in Desmos, check and see what it looks like on Desmos. That's a perfectly fine way to do this problem. But a somewhat quicker way is to look at your zeros here. So what's the 0 for this first factor? X equals 3. What about here? X equals negative 1. What about here? X squared plus 4 equals 0. That's x squared equals negative 4. I'm taking the square root. Oh, I'm taking square root of negative. What's that tell me I get from here? I'm going to get imaginary. Can I see those on the graph? So I can't really see those on the graph. So I should have zeros at 3 and negative 1. Here's the problem. Look at all of your graphs. Where do they have zeros? 3 and negative 1. How do I know which one's which? The difference is going to be in your multiplicity. Which one of these would have a multiplicity of 2? 3 or negative 1? It comes from the fact that you've got this square right here. Square means it should be written twice, right? So this one right here is going to be a double root. And what does it look like on the graph if we have a double root? It bounces off of that x-axis. It just goes down, touches it, and goes right back. So for A, both of these are double roots. Is that one correct? No, because they're both double roots. For B, right here is my double root. That's at 3. Is that the one that's supposed to be a double root? No, it's not B. For C, I've got negative 1. That's a double root. 3 is a single root. So C is the only one it could be for this particular graph. Now, Desmos is not a bad option either on that. Certainly go try that. All right, so just a couple more things. These last ones should go pretty fast. Writing equations from zeros. So we really just talked about this a second ago on the one with the imaginary one. We knew x equals 2 was a 0, so we knew x minus 2 was a factor. So if x equals any number is a 0, then x minus that number is a factor. So, for example, if I know that I have a third degree function and it has zeros at x equals negative 1, x equals 2, and x equals 0, then one possible equation for this would be x plus 1 times x minus 2 times this x right here. Now, if I wanted to, I could have called that x minus 0, but I don't need to call it x minus 0 for that. So, that negative 1 becomes x plus 1. The positive 2 becomes x minus 2 as a factor. and then the 0 is going to become just the x, because it could be written like this, x minus 0, but x minus 0 does just equal x, right? This is one possible equation. It is also possible to multiply this by any number you would like, and it's still going to have the same zeros. Let me show you what I'm talking about here on Desmos real quick. So if I take Desmos and I graph that equation that I just had, equals x times x, what was it, plus 1, x minus 2. All right, and I'm going to hit the house button. I'm going to get rid of that. Okay, so you can see this has zeros at -1, 0, and 2. If I put the number 3 out front, did it change the zeros? Did they move? They did not. It stretched it out, it made it taller, but it did not change. If I change that to 7, did it change the zeros? It did not. What about if I make it a -2? It changed, it even flipped it this time, right? But still the same zeros. So it could have any number up there as that's what we call the leading coefficient. Let's write that down. Hold on. Right here. This number right here, we might want to write that down. Whatever number is multiplied out here, that's your leading coefficient. Okay. A coefficient is just like a number that's being multiplied by a variable. So that leading coefficient can be anything. It can be 2, it can be 7, it can be 44, it can be -15. You would still have the same number, or zeros at the same spot. Okay? All right, so we'll get this done in 4 minutes so you guys have a little bit to work on your assignment. All right, so this is really pretty simple. Second period was doing great with this. Write a possible equation that has exactly 3 real zeros. So if I want to write this equation, I could use y equals, I could use f of equals. X minus 3, or x equals 3. The factor that goes with it is x minus 3. What would be the factor that goes with x equals 5? X minus 5. What would the factor be that goes with x equals -2? X plus 2. Perfect. Now, you can put any number you want right here. You could put a 7, you could put a 10, you could put 100. Why make it more complicated than it needs to be? I'm not going to put anything. I'm just going to write it like this. Okay, we all right there? All right, 12 is slightly more difficult, but really not much different. We have a leading coefficient of 2. We have a 4th degree polynomial. We have zeros at 2 and 0, and a 0 at -3 that has multiplicity of 2. So 4th degree polynomial is going to have 4 zeros, but we got 2 of them that are single, they're multiplicity of 1. We got this one right here that's a double, so that really counts as 2 for that. So if I have a leading coefficient of 2, that just means that number out front is a 2. And then I have zeros at x equals 2, so that's going to be x minus 2. And x equals 0, I could write it as x minus 0 if I want, but do I really need to put the minus 0? That just equals itself. I'll clean that up here in a second. And then I've got a -3, so that would be x plus 3, but it has a multiplicity of 2. So in the equation, what's it look like if I got a multiplicity of 2? The squared. Perfect. It's going to be squared right there. So now, if I just ask you to write it, this is perfect. You can stop. Now, if it's multiple choice, they're going to probably write it like this. 2x times x minus 2 times x plus 3 squared, because anybody that knows what they're doing wouldn't really write that minus 0 because anything minus 0 is just 0. So they just take that x and usually they'll put it right there. We okay there? All right. Questions? All right, so here's another one. We got zeros, -2, 0, 3. Now they're asking us to do this from a graph this time. So I would have f of x equals for -2, I'd have x plus 2. For 0, I'd have x minus 0 or just x, right? And then for 3, I'd have x minus 3. But you got to think about your multiplicity here. Do you have any of those that are double? Which one is it, Isaac? Not the 2. It is not doubled. That one in the middle is doubled because for a double 0, you just like touch the x-axis and then you go back down. You just kind of bounce off of it. So that happens here. It doesn't actually cross. So that is the one that is double, which is at 0, right? So this right here would need to be squared. The others could just be to the first power. And so because that x minus 0 is just an x, they're probably going to write that like this, x squared times x plus 2 times x minus 3. Like that. And I want you guys to have time to work on your assignment. So let's just talk about how to do number 14, and we're not going to do it. How in the world would you figure this one out? Which of these is equivalent? Let's just put them all in Desmos. Because factoring this to see what matches is not going to be good. All right. Now, to help you a little bit, so you don't have to type all the answer choices in, this is t to the first power right here. That's t to the first power. That's t to the first power, but that first power is squared, so it actually means there's 2 of them there. So you got 1, 2, 3, 4. You got 4 degree here. Right? So which one of these would not be the correct answer? D is not going to be the correct answer. I would also rule out A because this has a greatest common factor of 2t, right? That 2t has been pulled out. Does A have a greatest common factor of 2t? No, because it's got 16 that doesn't have any t's with it at the end. So I'd also throw that one out. So then you only have to check B and C. It ends up being B, I think. You're just going to graph it, graph the original, graph the choices, see which one has the same graph. I'm not going to spend time on that right now. All right, so we got about, well, not quite 15 minutes. Your assignment for today, it's actually on Canvas. It is going to show up as being on tomorrow's assignment because I have a doctor's appointment. I'm going to miss second period tomorrow. So I went ahead and gave them notes today. They didn't do this assignment. So it's actually on tomorrow. I also have not set the due date until Monday. That's really for my second period. I can, well, you guys have it tomorrow because that way we can check it. I don't want to stretch it out to Monday for you guys because you guys will be normal. I should be back by the time our class starts here. So it's going to be on student.desmos.com. You're going to go to the 3.4 assignment, polynomial zeros and factors. So it's on Desmos Classroom. So student.desmos.com. You're going to go to Desmos Classroom. And it should look like should look like this whenever you see this. So it's going to ask you for all of the zeros for some of these. There are a couple that are matching to the equation, and then the next slide will check it for you, like we've done a couple of those. Most of them are multiple choice. A couple of them might ask you to type it in. So, you can type in f of x equals, and this will let you do like x minus 4 to the second if you want. It'll let you type it like math right there. So, there's 10, but 2 of them are check-in slides, so it's really just 8. Go ahead and get started on that. You can get hopefully a few of those done before you go.